Okay, good morning class. So today we're looking at the November paper 2 2018. At this point we are busy with question 9. So we said that the proof of 9.1 is in the find the link to the proof below. So in the description box you'll find the link there in this video as well, in this description box as well. You'll find two links. One will be the link to the paper and the other one to the electronic copy of the paper, and the second link will be, or the other link will be the link to the proof for all the Euclidean geometry proof that's required in grade 11 and 12. Okay, so those of you who want to study the proof over the December holiday, summer holiday, you guys can do that. For those of you who want to do certain topics in the holiday in preparation for next year, I can give you those as well. Okay, but don't do it now, because you got better things to do now. No? Let's prepare for your November exam. Okay. Okay. Ja, moetje.
Ja, mevrouw.
Jongvrouw.
Huh?
Nee, jongvrouw. Ou man met 'n jongvrou.
Ek is ook by ek is geweest.
Alright. So this proof here is also will be in the links below. Okay, we're not going to spend time on that now. Let's carry on. So now we are 9.2, no? So we are told in 9.2 in the diagram O is the center of the circle. If O is the center of the circle, what do we know? We know that angle P1 and 2, the combination thereof is going to be 90 degrees. Also, if this is the center of your circle, angle O1, okay, that's not going to work because I was looking at angle at center is twice angle at circumference. So A2 is, double A2 will give you O3. Can you see that angle at center is twice angle at circumference? And many other things it tells us. These isosceles triangles that's being formed and all of those things, okay? Then, we are told that ABP and circle ABP. BP is produced to M such that OM is perpendicular to AB. Okay? Then, so you see there's 90 and there's 90. There's probably a link that's going to happen there. So AP intersect OM at on. Okay? And then O2 is equal to 20 degrees. So everything that is given here is in the diagram. Can you all see that, people? So I'm just going to put this on the side. I'm going to make it a bit smaller. Okay, I must leave it aside. Okay? So the first question says, calculate in 9.2.1. It says calculate with reason the size of A2. So A2 is here, not so? But we already indicated that A2 is double A2 is O3, not so? And in this point I can actually calculate O3, so it's angles on a straight line. So angle O3 is 180 minus 20 minus 90. This is 70 degrees. Why? Angles on straight line. Alright, so that is 70. So O2 is going to be, sorry, A2, not O2. A2 is going to be half of 70, which is 35. Why? Angle at center equals 2 times angle at circumference. You can't just say angle at center, okay? Just say angle at center is twice angle at circumference. So that is 70 and that is 35 degrees. Okay. The next question says, nine point two point two. No, sorry, 9.2.1 B says calculate P2. No, is that P2? So we know that OA is equal to OP. Sorry, is it P1? Okay, it's fairly small. So it's P1. Okay, so for P1, I already indicated that that's 90 degrees. Not so. So this is now P. It was A. So A PB is equal to 90 degrees. Why? Angle in semicircle. Alright, so P1 should also be 90 degrees. Why? So its angles on a straight line. Okay. The next question says, hence or otherwise prove that AOPM is a cyclic quad. AOPM. Now for this to be a cyclic quad, it will be one of three options. Opposite sides are supplementary, exterior angles equal to the interior opposite, or the bow tie. No? Angles in the same segment. So you see these diagonals here, so if we can prove that that angle is equal to that angle, we've done the job for angles in the same segment. But these are already equal to 90. Can you see that, people? So we just state the obvious, very important. We say since, it's 9.2.2, we say since, we know that P1 is equal to O1, angle O1, which is equal to 90 degrees. Therefore, AOPM is a cyclic quad. Why? Because equal angles subtended by the same chord. The equal angles subtended by the same chord, in this case is called AM. So then, since those angles are equal, that has to be a cyclic quad. Now all cyclic quadrilateral properties are now evident in this diagram now, okay? In quad AO, P, M. Okay? I'm marking here for you. Why? So that I can see now that is also a cyclic quad. Okay. In the next question, you are asked to calculate the size of M1. Calculate the size of M1. And where's M1? Here. There's your M, no? You put M here. There's your M1. So if we look at M1, M1 is the same as A2. Can you see that, people? I'm running out of colors here. Can you see the angles in the same segment? Why? Because that is now a cyclic quad. Okay? So we can say that M1 is 35 degrees. I'm taking this off. I want to keep the diagram in focus. So M1 is equal to 35 degrees. Why? The angles in same segment, and it's coming from arc O. What is this? P. Huh? That is 35 degrees. Then the next question says, name with reason one other cyclic quadrilateral in the diagram. Where else is cyclic quadrant? O? P, B. Why? O2 plus O3 is 90 is? That's your exterior angle. Nice. So since, you see here, here's the cyclic quadrant. Okay? The exterior angle is equal to the interior opposite. Okay, so you must just state it. We just say since, you state the obvious first. Angle OLB is equal to angle P1, which is equal to 90 degrees. Okay? Why is that 90? Proven 90 now. So therefore, OBPL is a cyclic quadrant. Why? So the exterior angle equals the interior opposite angle. Just remember, when you're proving something is cyclic or cyclic quad in this case, do not say in your reason cyclic quad, because I'll be proving it's a cyclic quad in this case. Okay? So that's that. 2 marks. Alright, and that's it. Let's go to the next question. The next question we are told in 9.3. In the diagram, 2 circles. The diagram, a small circle ABTS, and bigger circle BDRT are given. BT is a common chord. BT is a common chord, which means you say it's a chord in both circles. Straight line STD, yes, and ATR are drawn. Chords AS and DR are produced, which we need to extend it to meet at C. A point outside of the circle, BS, and DB are drawn. Angle A is X and R1 is Y. Right. So everything that is given there in the description is definitely on this diagram. Okay. Let's hope this is going to work. It's a little smaller. Right, let's go to the first question. First question says, name giving reasons another angle equal to X and another angle equal to Y. Okay, so 9.3. Right? So if this is your X here, then of course B1 is X. Not so? Angles in the same segment. So B1 is equal to X. Angles in same segment. Okay. Then in B they want you to name another angle equal to Y. So as you can see, there's a cyclic quad here. Oops. This here is a cyclic quad. So that's your exterior angle of the cyclic quad. So it's going to be B2. Can you see that? So B2 is Y. And we said it's going to be exterior angle of cyclic quad equals the interior opposite. Okay. Let's take this arcs out here. The next question says prove that SCDB prove that SCDB is a cyclic quadrilateral. For this to be cyclic, must prove one of three things. Either opposite angles are supplementary. So if I can prove that C is 180 minus x plus 1, then I've done the job. Or you can prove that S1 is equal to, the exterior angle is equal to the interior opposite. So S1 is equal to the sum of D1 and D2, or the bow tie. There's no bow tie here. You see, the second diagonal is not evident there, so the bow tie won't be able to apply. Okay. Right, so we're going to try and prove S1. So S1 is the same as T2. Those angles in the same segment. Okay. T2 is also equal to P2, which is your y, you're picking up your y, and D1. Can you see that? So if I can prove D1 is x, I've done the job. Is SB a tangent? If SB is a tangent, then that would be the case. Nope. They did not say it's a tangent. So that's not going to work. Okay, here I can go with sum of triangles here. Right, there we go. Can you see it? In that triangle I can say that angle C is going to be 180 minus x plus 1. You all agree with that? Why? Sum of triangles, interior angles of a triangle. So angle C is equal to 180 minus x plus y. The reason is the not exterior angle, but sum of angles in the triangle, and it's triangle ACP. Here 180 minus x plus 1. Okay. Now you see that opposite angles is 180 in that quadrant. You all see that, people? So now we state the obvious. We say since angle SBD plus angle C is equal to x plus y plus 180 minus x plus 1. And of course that now cancels, gives us 180. Opposite angles are supplementary. Therefore, SBDC is a cyclic quad. Why? Because the opposite angles are supplementary. Okay? So that means to say that all cyclic quadrilateral properties, cyclic quads properties, are evident now in the squad SBDC. Does this make sense? We're moving too slow. Can we move a little faster? Okay. So let's look at the next question. The next question says, it is further given that D2 is further given that D2 is 30 degrees. So is D2? D2 is 30 degrees. And AST, this angle here, is equal to 100 degrees. Prove that SD is not the diameter of a circle. SD is not the diameter of a circle. SD, where is SD? Oh, yeah. Okay. So the question is, if SD was the diameter, then what can we conclude? That angle C would have been, if this was the diameter, what would we have known? Whoops. If this was the diameter, then this angle would have been 90. Not so. So to prove that it's not the diameter, we prove that that angle is not 90, in other words. Does it make sense? Right. So let's go. So we're going to now prove that that angle is not 90. Now remember, they gave us that to be 100 degrees, this to be 30 degrees. Can you see that? So what we say is, okay, let's see. This is a triangle here, not so. And this is your exterior angle of the triangle. Can you see? So it's easy to calculate C. So we say that angle C is equal to 100 minus 30 degrees. Can you see that? Which is 70 degrees. The angle C is 70 degrees. So we say, since angle C is not 90 degrees, okay, therefore SD is not the diameter. Okay, reason? Because of, how many marks is 4 marks? So that's, we need a reason. For the 4th mark. Because you must remember that the diameter subtends 90 degrees. So you say that chord SD does not subtend. Okay. Right, you guys understand? Was there a bonus question here? No, I think we introduced the bonus question here. I think it was it. Did paper 1 have a bonus question? No, so it was in 2019 that we started bringing in the bonus question, okay? So that time people came very close to full marks. Okay, and I said, okay, let's see what we can do for them. But you guys, you don't even, that bonus question doesn't even bring you close to full marks. But you guys are going to try harder, most, no? Right, let's choose the next paper we're going to work on. Let's stop the video first.